Master T Math class. And in this live class, we want to look at this topic on circle geometry. Now we need to understand first some part of the circle. When we have a circle, the distance around the circle here is what they call circumference. And here we have the center of the circle. Then there are some parts of the circle that we need to understand. A line drawn from the center of the circle to any part of the circumference is what is called radius. So this line is a radius. And also we have a diameter. Diameter is 2 radius. That's 2r. So when we balance this, and we have another radius from here to here. So a line that's, so radius means, diameter means 2 radius, which is a line that passes through the center and touches the circumference at 2 sides here. So, and pass through the center. That's what they call diameter. So everything here is diameter. So we can draw it another way, this way, and call this diameter from here. So this is diameter. And here we also have some, other parts. Like we have a line drawn from one part of the circumference to the other. So I have this line now. This line is called a chord. So we have a chord here. So these are the parts of the circle we need to understand. And also here, we have some regions here. A region bounded by an arc. This arc, any part of the circumference is called arc. So we have this part, cut. If I cut this part here, this is an arc. So a region that is bounded by arc and a chord is what is called segment. So, and if I have a circle this way, then we have a segment. This is center. This arc here and this chord, let's label it as AB. This region here is what they call segment, and it is a minor segment. So we also have the major segment, that is this big arc here. If this is C, this is D. So we have arc, small arc ACB, and also we have big arc ADB. So these are part of the circle. So we have two segments, that is cut out by this chord, the minor and the major. Now, the important one we need to know here very well, that we need to be familiar with what they call the diameter, that is a pass through the center, and also we need to be familiar with the radius very well, a line from the center to the circumference, and also we need to be familiar with chord very well, that is a line drawn that touches the circumference on both sides. Also, we need to be familiar with arc very well. Now, let's go to the circle theorem. And before we state the first theorem under circle, we need to understand something first. For instance, we should understand that when we have a circle with a center, okay, let's make it smaller. We have this circle, center here, then a chord AB given here. Now this chord subtends two angles at the center. That is, it can form two angles at the center. The first line going to the center, also the second line, the second point here, going to the center and forming the angle at the center from this point A and B. So this chord forms two angles at the center. We have the obtuse angle here, okay, and we have the reflex angle here. These are the two angles that is formed by this chord AB. And sometimes we might look at it in form of arc. So if I label this as AB, it means we are considering this arc AB. So a chord or an arc can form an angle at the center, and which are two angles. We have the obtuse one, the one inside here, and we also have the reflex angle, the one outside here. So that is the first thing. And also we should understand that a chord as well can form angle at the circumference. This is the center. When we have this chord, or we might call it arc when we clean this. So here, this can form angle at the circumference of the circle, like any part of the circumference. So this arc here, this chord here, form this angle at the circumference. So we can label this point as B. On this side, which is at the major segment, then also can form another angle here at the minor segment. When we label this as C, so these are the two angles at the circumference that this chord can form. So that's something we should understand about circle. When a chord subtend an angle at the center, we have two angles. When it subtend an angle at the circumference, we also have it two ways. You can subtend it at the upper side, which is the major segment, and also can subtend it at the lower part, which is the minor segment. And also we have a diameter. A diameter is a line that passes through the center and touch the circumference on both sides. Now, diameter also can subtend angle at the circumference. And there is a theorem for this. Because when we have a diameter divides a circle into two equal parts, which means we have semicircle now, half half. So angle in a semicircle, that's what it means. So a diameter, when it subtends angle, it means angle in a semicircle and is angle 90 degrees. When we get there, from theorem 1, we are going to deduce this theorem and is in another theorem. So these 3 points are very important. Now let's look at the first theorem. And the first theorem we are looking at here is what all other theorems hang around. So we call it theorem 1 here. Theorem 1. And this theorem states that the angle which a chord or an arc of a circle subtend at the center is twice that which the chord or arc subtend at the circumference. At the circumference of the circle. That's the first theorem, and we are going to look at the proof of it. The angle which a chord. So the key word we have here, we have chord, or it might be arc or a circle. So circle is very important. At the center is twice. So this statement, twice, is what is connecting that theorem. That's times 2. That which the chord or arc subtend at the circumference of the circle. Now, to prove this theorem, So the proof of this theorem goes thus. We need to write out what is given and demonstrate it in a diagram. So we have a chord. Number one, we are given a chord. We can say let it be called AB, a chord of a circle AB. So we can draw that and we have it this way. Okay, let's make the diagram. So we have the center hole of the circle. Let's have the chord this way, and let's call it AB. So we can say we have a circle center hole, a chord AB, and also we have angle at the center. Angle at the center, let's call it. So we have angle at the center, and in this case, since this is O here, when we draw this here, we have two angles at the center here. So let's consider the obtuse part here in this diagram. So we have the angle at the center, which is obtuse angle AOB. Then also we have angle at the circumference, which is the third one. Angle at the circumference that is formed by the chord. So let's use this chord now to form angle at the circumference here at the major segment. So let's call this point C here. And that angle at the circumference is now angle ACB. Okay, now that is it. To prove that what are we proving? To prove that angle at the center, which is angle AOB, the reflex angle AOB, is equals to 2 times, that's twice, the angle at circumference, which is angle ACB. So that's what we want to prove. Now there's something we need to do there. And that is called construction. The next point here is construction. So we need to make a construction here. And what we need to do is to join line C, point C to point O, and extend it to an external point. So join C to O and extend to point, let's say D. Now we can show it from the diagram here. So we join this point to point O and we extend it to point D. So let's call this point D. We can draw it and extend it out to where we want. And we can stop it somewhere here. So we should just make sure it's past the point O. So we have D here. Then, after construction here, then we can go to the proof proper. So proof now, from what we have now, we can see here that this line we draw now has divided this into two triangles. So we look at this triangle AOC. Now, triangle AOC there, when we look at it from triangle AOC, we have line AO is equals to line CO. Line AO is equals to line CO. Why? Because they are radii of same cycle. Both are radii. They are radii. And when we have radii, when we have this side to be the same thing as this side, we have two sides equal. So here we can say that, therefore, triangle AOC is an isosceles triangle. When two sides are equal, it means they are, and base angle and also triangle are also equal. So here we can say the base here will be equal. So hence we can label this angle, which is OAC now, or angle, anyone want to call it, you can say angle CA. When we are using three letter, the angle we are referring to will be at the middle. So here we say angle CAO is now equals to angle ACO. Angle ACO. And we can call it letter X since they are equal. So let's call this angle letter X and also call this angle letter X. And from here, when we have a triangle and a side is extended, for instance, this triangle we have here, this is how it is. So this side is the one that is extended, and we call this X, we call this X. So when a third side is extended in a triangle, there's something there which is called exterior angle. This exterior angle now will now be the sum of the two opposite interior angles. So it will be X plus X, which will be 2X. So here we can now say from here that therefore we can say angle AOD here, which is this angle outside here. Angle AOD will now be equals to 2X. That's exterior angle of triangle AOC. So here we can put reason base angle of isosceles triangle, because everything we are doing on that circle, we must back it up with the reason why. Now, if this is 2X, now let's put 2X here now. Then similarly, we can do that to the other triangle. So that's what we need now. We say similarly from triangle BOC, from triangle BOC, also line BO is equals to line CO. When we are referring to line, we can use, a line on it like this. Why are they equal? They are also radii. That is, BO is a radius, CO is a radius. It means that triangle BOC now is also an isosceles triangle, and base angle of that also are equal. So this angle is equal to this angle, which means we can say angle CBO. So I can say therefore angle CBO is equal to angle BCO. And let's call it Y since they are equal. So that's base angle of an isosceles triangle. Then from there, also here we have the exterior angle because of this that is extended. So let me write this B here for us to have space. Now, this angle is also extended. This triangle is extended. So, and it will be sum of the two opposite angles. So this is 2y. So we can say angle DOB or BOD, whichever. So therefore, angle BOD is also equals to 2y, exterior angle of triangle BOC. Okay, now we can make a conclusion here now. And when we look at the angle at the center, everything at the center, this obtuse angle now, which is AOB, that angle now, the total angle there is 2x plus 2y. So conclusion now, we can say that since angle AOB is same thing as 2x plus 2y, 2x plus 2y, here we can solve further and we factor 2 out, and we have 2 into bracket x plus y. Okay, and when you look at this angle at the circumference, which is ACB, the total angle here, which is ACB, is x plus y. So from then we have angle ACB at the circumference, that's equals to x plus y, which implies that instead of writing this x plus y, we can easily write angle ACB. And therefore, finally now, angle AOB that we have here is now equals to 2 times x plus y, which is angle ACB. So here, the required here has therefore been proved. So therefore, we are done with the proof of this theorem. So that is how to go about that. Then we can use this to solve so many other problems which can be applicable to this theorem. You're watching us live at Master T Math Class. We appreciate you for joining. Don't forget to subscribe to this channel and give your thumbs up. Also share this video. So now let's look at one question here to apply this particular theorem 1, 2. So we have like 9 of the theorem. Next class we continue. But before we round up here, let's look at one question here to back this up from this theorem. So let's look at this. We are given this diagram. We have a circle which is center hole. Then we have a radius this way. So another one this way. We have this. We have this. So here we are not having anything like, okay, let's look at it. The way this one is a little bit, different, but we need to see what they mean there. So we have this angle at the center, they call it x. An angle at the circumference here, we call it y. And this is labeled, this angle here is labeled as 32 degrees. Then this is labeled as A, this point A, point B, point C, and point D. Now, the question here is that we should find the value of x and y. Now, one thing we should understand is that this x here is angle at the center. And we have two angles at the circumference. One is at the upper part here. That is not drawn up like this. That is not drawn up like this and touch the circumference at this side. Doesn't make it not to be angle at the circumference. So that is bent like this. It is still at the circumference. So the same thing as putting it up here. And when you look at that, it is this arc BD that subtend this angle. So its angle can be subtained by either a chord or an arc. That's where it started from in this class. So when you look at this chord, this arc BD, it subtained two angles here, subtained even three angles. One at the center here, one at the circumference here, also one at the circumference here. Okay. Then there is, from that theorem 1, let's quickly look at the first one, the first diagram we draw. So we saw it like this. That is, we have, now we don't have a chord, so we can use an arc. So we have angle at the center and we have angle at the circumference. And we say angle at the center now is twice the angle at the circumference. So if that angle at circumference is x, angle at center is expected to be 2x. That's the proof. That's the theorem that we just proved. That means angle at the center is twice the angle at circumference. Then the opposite is also true. Now, You know, we have two angles at the center. For instance, if the angle at the center now is considered to be this reflex angle here, its angle at the center, this angle at the center, its angle at circumference will be this side. So when it is obtuse, it will be up. When the angle at the center is reflex, the angle at the circumference will be down. So if this is y, this is expected to be 2y. Okay. Now, easily here we can get the value of x, because this is obtuse, its angle at circumference is up, which is this. So x will now be 2 times 32. That's angle at center is equals to 2 times angle at circumference. So that's the reason to back it up. And therefore, x here will now be 64 degrees. So now, if x here is 64 degrees, we can get this reflex angle here. How? By saying angle at the center. So that reflex angle BOD will now be equals to 360 degrees minus 64 degrees. And that will give us 296 degrees. Yes. So that's the angle reflex. Well, that's not where we're going. We are going to this place. The corresponding angle at the circumference to angle at the center here is y. So since the center is bigger than the circumference, so we just divide the center by 2. So y will now be equals to 296 degrees divided by 2. It's still the same reason as angle at center is equals to 2 times angle at circumference. Same reason. Then that gives us 148 degrees. So that is it. So that is how to handle problem using the theorem 1. So we still have another one from here. Let's look at another question to back this particular theorem up from here. Okay. So we are given this diagram, which is centered at point O. Then we have this as radius, also this as radius. This angle at the circumference, and here is labeled as 26 degrees. Here, everything at the center here labeled as 130 degrees. So there is a line that is drawn here from the question. Okay, this angle at the center is 130 degrees. Also, there is a distraction line that is drawn like this. So this line is just a distraction line, and they label this point as A, this point as B, this point as C. So the question says, the first question says we should find angle C, okay, we should find angle CBO, and we should find angle BOC. So two angles we are finding. The first angle CBO, when we have three letters like this, is referring to the one at the center, connected from this to this. So we have CBO. So this angle, we are finding this angle. And also, we are finding BOC. BOC, we are finding this angle as well. Now, when you have this, the first thing to look at is this is from theorem 1, which is angle at the center is twice the angle at the circumference. which implies that angle at center here is given, and that is 130 degrees. Now, but here, they even help us by drawing this line, and that makes line AO to be equals to line CO, and those are radius. So therefore triangle AOC is an isosceles triangle. So we can say base angle are equal. So this angle here will be 26 degrees, which implies that angle ACO, the angle I mark now, is equal to 26 degrees. We can say that's base angle of an isosceles triangle. And now, when we reference this angle at center, everything here is its angle at the circumference, so we can get it. An angle at center is bigger than angle at circumference, so we need to divide this by 2, which implies angle ACB, the whole of this angle at the circumference, will now be equals to 130 degrees divided by 2. Still angle at center equals to 2 times angle at circumference, and this gives us 65 degrees. So if everything here is 65 degrees and we already know 26 here, we can get the remaining one here. That will simply be 65 minus 26 degrees. Okay, so it implies angle BCO. Angle BCO is now equals to 65 degrees minus 26 degrees, and that will equals to 39 degrees. So this angle here is 39. That's why everything here is 65. Okay, and also triangle BOC is an isosceles triangle. Triangle BOC is an isosceles triangle. Two sides are equal. OB is equals to OC. That's radar. That's the reason why they are isosceles. And here, base angle will be equal as well. So this is 39 degrees. The angle we are finding here now is also 39 degrees. So therefore, the first number one here, which is angle CBO, will be equals to 39 degrees. That's base angle of an isosceles triangle. Then it's easier to get this now, which is angle BOC. Why? We already have two angles in a triangle. So, and sum of angle in a triangle is 180 degrees. So we can subtract the sum of these two from 180 degrees, which means number 2 now, which is angle BOC, will now be equals to 180 degrees minus 39 degrees plus 39 degrees, that's 78 degrees. That's sum of angle in triangle BOC, and that will become 102 degrees. So that is that. I believe you enjoyed this class. So you are watching Master T Math class. We upload video here daily. We solve maths. So do well to subscribe. And also, do well to subscribe in order not to miss out on our upload. I believe you enjoyed the class. So thank you. God bless you. And have a wonderful day. See you next class and bye for now.